All right, today we're going to start talking about systems of equations. A system of linear equations is when you have two or more linear equations. Linear means your degrees, exponents are ones. You don't have squares or cubes or anything like that. The solution of a system of linear equations is the xy coordinates of the intersection point. Graphically, this would look like this. They've graphed x plus 2y equals 2, and we'll go over review on how to graph, but they graphed that is the blue line. They graphed x minus 2y equals 6 is the red line, and right there where they intersect is the solution. So the solution to this system would be 4, negative 1. When you do it algebraically, the xy coordinates have to satisfy both of these equations. So if I changed my x to 4 and my y to negative 1 in both of those equations, I have to get true statements or it's really not a solution. So if I test my first one, I'm going to change x to 4 plus 2 times y to negative 1 and see, does it equal 2? Well, this would be 4 minus 2, which is 2, which equals 2. So far, so good. It still doesn't mean it's a solution unless it works in both equations. So if I check the bottom one, change x to 4, minus 2 times y is negative 1 equals 6. 4, that's going to be plus 2, 6 equals 6. It is true in both equations, so yes, it is a solution. All right, so let's review on how to graph, okay? First thing you do is get your equation in y equal mx plus b form, slope-intercept form, which means get y alone. You're going to plot 0b, which is going to be the y-intercept, and then you're going to use your slope to rise and run to the next point and connect them. All right, so I have a little story for this. All right, the story is someone has taken your beautiful babe, okay? Beautiful babe. See how they start with B? Because that's to remind you that that's the B coordinate. Someone has taken your beautiful babe, and they've kidnapped him. Your job is to go save him or her. Okay? This is your only clue as to where they've got him or her. So what you do is, this is like your treasure map. You have to decipher it. It's coded, obviously, and you can't read it until you get y alone. So to get y alone here, I'm going to minus x from both sides. That gives me negative 2y equals negative 1x plus 6. You don't have to put the 1, but I think it helps when you're trying to graph for sure. So now to get y alone, I'm going to divide by negative 2, and I get y equals 1/2 x minus 3. Now I can read the code. And what this says is, it's saying, hey, I've got your beautiful babe, and it's in this coordinate system, and it says this is my y-intercept. So your first place to try and intercept her is at this number on the y-axis. So I go there. I go to negative 3 and I knock on the door. Mark it because you're going to connect to it. That's your first place you looked. But unfortunately, your beautiful babe isn't there. Instead, there's this dumb monkey standing there with your next clue. I call it a monkey because it starts with M, and that's my M for slope, yeah? So the monkey says, hey, give me some peanuts. I don't know if monkeys like peanuts, but give me something. Banana. Give me a banana and I'll tell you where your girl is or your guy is. And so you pay the monkey, and he says, look, go 1 floor up and 2 rooms over, and you'll find her. So from there, I go up 1 and over 2, and right there, I find her, or him. All right, and so now all you have left to do is make your getaway and run like crazy. And you got her back, or him. Okay, so there's a little review of graphing. Why are we reviewing on graphing? Well, because when you solve a systems by graphing, all right, you're going to graph each equation, get each equation in slope-intercept form. You're going to graph each one, and then wherever they intersect, that will be your solution. Now, 3 things can happen when you graph 2 lines in the same coordinate system. One, they can intersect. And if that happens, you have exactly one solution. And we call the system consistent and independent. The second thing that can happen when you graph two lines in the same plane is that they never, ever, ever intersect. If that happens, you have no solution because you have parallel lines. They're never going to cross. And we call that system inconsistent. And the third thing that can happen is they can actually give you the same line but with two different equations. When that happens, you basically have the same line graphed on top of itself, which means there's infinitely many solutions because they share every single solitary point. All right, so we call that system consistent and dependent. So as long as you have solutions, you can say it's consistent. If there's one solution, it's independent, like one, singular, on my own. I don't need anybody, I'm independent. If they share every point, then one line depends on the other, so that's dependent. And then obviously, no solution would be inconsistent. All right, so it says solve by graphing and then classify the system. Well, I can't graph that first line until I get y alone. So I have 2x minus y equals negative 1. I'm going to get y alone, so I'm going to minus 2x. That gives me negative y equals negative 2x minus 1. Divide by negative 1. And I get y equals 2x plus 1. So, hey, where's my beautiful babe? Remember that I'm going to intercept, try to intercept and save her or him at 1 on the y-axis. Remember, it's a y-intercept. You always are going to check the y-axis first to see if your babe's there. The monkey says, give me a banana. So you give him a banana and he tells you where to go, which is 2 floors up, 1 room over. Connect. And there's my first line. All right, to graph my second line, 2y plus 5x equals negative 16. To get y alone, I'm going to minus 5x minus 5x. I get 2y equals negative 5x minus 16. Divide by 2. And I get y equals negative 5 over 2 minus 8. X. Don't forget your x. So there's where I'm supposed to intercept my beautiful babe, negative 8 on the y-axis. Not there. Give the monkey a banana, and he says go down 5 and write 2. 1, 2, 3, 4, 5 over 2. So about right there. And if you're out of graph, you can, if I'm trying to do a negative 5 halves, I can actually put the negative on the bottom. And then this would say go up 5 and left 2. So I can do that. 1, 2, 3, 4, 5, left 2 is right there. Connect and run away with your babe. And now we can get the solution is right there. Okay? So let's see, that would be at negative 2, negative 3. Those would be the coordinates. So my solution is negative 2, negative 3. Yeah? Alright, so if we solve this one by graphing, and I said, yuck, y alone isn't very pretty. I wonder what I'm talking about. Well, let's try and get y alone on this first one. 4x plus 5y equals negative 41. I'm going to minus 4x minus 4x. I get 5y equals negative 4x minus 41. Divide by 5, divide by 5, divide by 5. I get y equals negative 4/5 x minus 41/5. Well, to graph that, where the heck is negative 41/5? When you're graphing, you want to keep your slope as a fraction, but you want your y-intercept as a decimal because I don't know where negative 41/5 is, approximately. I can type it in a calculator, and it's approximately negative 8.2. So, again, you're graphing, and I'm going to go down to negative 8.2, which is not very accurate. And this is the whole point of picking such an ugly equation, is to show you that while graphing is a pretty easy technique of solving a system, it's also the very least accurate unless you're graphing with a computer. or at the very least, a ruler, which I'm not. Okay, so when you're estimating, again, that's where graphing isn't hard, it's just not very accurate because of human error. Anyway, so I did that. I got to go down 4 and right 5, but I don't have enough room, so again, I'm going to put my negative on the bottom and go up 4 and left 5. So that's going to be approximately 1, 2, 3, 4, 1, 2, 3, 4, 5. It's going to be approximately right there. And if I connect, and again, I am not using a ruler, obviously, and that's why this gets very inaccurate. Okay, so there's my first line. And to get my second line, 3y minus 5x equals 5. Add 5x. 3y equals 5x plus 5. Divide by 3. And I get y equals 5/3 x plus 5/3. I gotta go find my babe. Alright, but where the heck is 5/3? Well, I type it in a calculator, and that's approximately 1.7. Okay, so if I start at 1.7, which is about right, no, that's 0.7. Hold on just a second, let me check my signs. Plus 5x, plus 5x, that's positive, okay. So 1.7 would be about right there. Alright, and then I'm going to go up 5, 1, 2, 3, 4, 5, and over 3, which is about right there. And if I connect those, alright, it's about right there. So now my solution is going to be right there, which is what? I don't know. I'm going to call that about -5, and I think I'll call that, I don't know, about -4.5. Okay, so now what's funny is, I don't know how bad I screwed this up. Yeah, it should be doing that. Anyway, -5, -4.5. What's funny is I actually typed this in the calculator, and the actual answer is -2. No, I typed it in wrong. Darn it. Well, I'm going to show you how to calculate this on the calculator in a couple slides here. What we're going to find out is that's not the actual answer. It's close, but it's not the actual answer. And again, why? Because graphing is the most inaccurate. I mean, look at my line. I'm not even lined up right. This should probably have gone down a little bit. I don't know. Okay, and that's the whole point of graphing. Isn't necessarily that hard. It's just that it's the most inaccurate. The other thing is, they're going to give you some weird things to graph. Like, what if they give you some stupid equation like this? Well, I said you want your monkey to be a fraction. I mean, how do I go up 0.125 and over 1? I mean, it's so minute. You know what I mean? It's not going to be very accurate at all. So what you can do is you can turn your decimal into a fraction. You just type it in and hit math, enter, enter, and it tells you that it's 1/8. And I want this to be a decimal. So if I type 4 divided by 5, I get, or -4 divided by 5, I get -0.8. So there's my babe, -0.8, which is almost to -1. And the monkey says to go up 1 over 8. So that line would be about like that. Okay? When you're graphing the second one, there's no x. So what's my M and what's my B? When you have only one of the letters, when it's just Y, you have a horizontal line through that number on that axis. When it's X alone, no Y, that's going to be a vertical line through 2 on X. So if I graph the Y one, I go to -3 on the Y axis, and I make a horizontal line through it. Okay, so that's how you graph a Y equation with no X. To graph an X equation with no Y, I'm going to make a vertical line through 2 on X, So that one would look like this. And then what about this last one? It has an m, but it has no b. Well, I can always add my own b. Adding 0 doesn't change the equation, and that tells me my babe is at, oops, I don't want red. I can write plus 0. That tells me go to 0 on the y-axis, try and intercept her. She's not there. The monkey says go down 5, 1, 2, 3, 4, 5, and over 1. And so that line would be that one. Okay, so little graphing tips. All right, you try this one, hit pause, come back when you're ready. And the answer is 4, 1. So on the top one, 3x plus 2y equals 14. If I get y alone, I'm going to minus 3x. I get 2y equals negative 3x plus 14. Divide by 2. I get y equals negative 3/2 x plus 7. So I'm going to go to my beautiful babe. I'm going to intercept on the y-axis. Monkey says go down 3 over 2 and connect. My second equation, all I have to do is divide by negative 1, which will give me y equals positive 3/2 x minus 5. So there's my beautiful babe. Intercept on y, not there. Monkey says up 3 over 2. And there's my intersection point, which out of my possibilities, it looks like the closest one would be 4, 1. Okay? Alright, so how do you solve a system of linear equations in two variables using the graphing technique? You graph both equations, and the point of intersection is your solution. Describe the solution to a system of linear equations. The point of intersection. Alright, so now we are going to learn some graphing calculator techniques. It says to solve systems by graphing using a graphing calculator, you still have to get y alone. Okay, you still have to get y alone. The calculator doesn't understand an equation unless y is alone. So then you're going to go to y equals, this key right here, and you're going to type in your equations. Then you're going to hit graph or zoom 6 to get a standard window. You might have to change that. And then you're going to calculate the intersection point. And what you do is you hit this key second, and you hit this calc key because we want, well, you're hitting the trace key, but we're trying to calculate. And then you're going to choose this intersect choice, and then you're going to hit enter basically 4 times, and you'll get your solution. Alright, so if we do this one, alright, I'm going to go to y equals, and I'm going to type my equations. Y is already all alone, so hit your y equal key, and you're going to type in, for y1, you're going to type 2x plus 1, and for y2, you're going to type negative 2/3 x plus 4. Then hit graph, and I'm going to hit zoom 6 to get a standard window, and there's my 2 equations. Okay, so now you're going to calculate the intersection point. So you're going to hit this second key and this trace key here, which will give you this screen, and I want the intersect choice. So that is second, trace, intersect, get you this screen. When I click intersect, then you're going to hit enter, and it's going to say first curve, hit enter, second curve, hit enter, guess. No, I don't want to guess, so just hit enter again, and it'll tell you your intersection point is at 1.125, comma, 3.25. Okay? Cool beans? Alright. So if we try another one here, the problem here is I can't go to my y equals until I get y alone in both of these equations. So if I take 3x plus 2y equals negative 2 minus 3x minus 3x, I get 2y equals negative 3x minus 2. Divide by 2, I get y equals negative 3 halves x minus 1. There's one of them. To get the second one, I got to get y alone. So I have negative 4x plus 5y equals negative 28. Add 4x. I get 5y equals 4x minus 28. Divide by 5. I get y equals 4/5 x minus 28/5. So now when I go to my y equals, I type in negative 3 halves x minus 1 and 4/5 x minus 28/5. Hit graph. There's my solution. To calculate it, I'm going to hit second calc 5 for intersect, and it shows me my intersection point is at 2, negative 4. So my solution is 2, negative 4. And I am so sorry, I keep forgetting to classify the system. Since there is one intersection point, that makes this system consistent and independent. And I'm very sorry I forgot to do that on like all the rest of them. But your chart is right here to classify it. One solution is consistent and independent. Parallel means no solution. Same line means infinitely many. Alright, so on this one, oops, I meant to animate that. If on my top one I get, trying to see where I've got room here. On the top one, negative 2x plus 5y equals 10. If I get y alone, I'm going to add 2x. That gives me 5y equals 2x plus 10. Divide by 5 by 5 by 5. I get y equals 2/5 x plus 2. So I type that in for y1. Now, when you do y2, 4x minus 10y equals negative 20. I'm going to minus 4x minus 4x. Negative 10y equals negative 4x minus 20. Divide by negative 10. And if I don't reduce, I'm going to get 4/10 x minus 20/10. If I reduce, it's going to be exactly the same as that. But I didn't reduce it so that I could show you, even though these equations look different, when I hit graph, I only get one line. What does that mean? It means these two equations are the same line. If I reduce this by 2, I get 2/5 x. Reduced by 10, I get, oops, that's a plus. Negative divided by negative. Plus 2. The two equations are exactly the same. It's just they made them look different because one's a multiple of the other. Okay, so when that happens, you get this, so there's infinitely many solutions. Infinitely many solutions, which means my system is consistent because there are solutions, and dependent because it's all of them, dependent. Okay? Alright, you try this one, hit pause, come back when you're ready. And hopefully you got one. Alright, on top here, if I get a y alone, negative 4x plus 5y equals negative 17. Add 4x, I get 5y equals 4x minus 17. Divide by 5, divide by 5, divide by 5, y equals 4/5 x minus 17/5. My second equation, negative 4x minus 2y equals 15. To get y alone, I'm going to add 4x. Negative 2y equals 4x plus 15. Divide by negative 2 by negative 2 by negative 2. I get y equals negative 2x minus 15 halves. So I type those in, 4/5 x minus 17/5 and negative 2x minus 15 halves. Hit graph, calculate intersection, and it's negative 1.46 if I round, and negative 4.57 if I round. Okay? Alright, try this one. Hit pause, come back when you're ready. And hopefully you got inconsistent. If I take my top equation, 6x minus 4y equals 15, minus 6x minus 6x, negative 4y equals negative 6x plus 15, divide by negative 4, and I get y equals 6 over 4x minus 15 over 4. I could reduce that, but if I do my second equation, negative 6x plus 4y equals 18, add 6x, I get 4y equals 6x plus 18, divide by 4, I get y equals 6 over 4x plus 18 over 4. I can tell you right now, because they have the same slope, that these two lines are parallel. If they're parallel, they never touch. Well, if they're parallel and have different y-intercepts. If both of those match, then it's the same line, and it would be 1. But these have same slope but different y-intercepts, which means they are parallel. If I typed them both in, they're parallel, which means no solution, which means the system is inconsistent. Okay? Alright, so how do we use the graphing calculator technique? Get y alone, type, calculate, intersection. You need to use complete sentences, and you need to make this much more detailed, but this is just kind of giving you a little trigger to remember. And describe the solution to a system of linear equations. Well, now we've seen it where there can be one solution or no solution, which is when they're parallel. Again, explain when that happens. Or infinitely many, which is when you have the same line, so explain when that happens. Alright, the next thing we're going to talk about is using a table of values to solve a system of equations. You're going to do everything exactly the same way as if you were going to do it by graphing. You still have to get y alone, you still have to type it in the graphing calculator. The only difference is, instead of going to the graph, we're going to go to the table. And what you do is you scroll through and you're looking for the x value where the y coordinates are the same. And that's at one place and one place only, which is at 5, 4. Whatever this system was, the solution is 5, 4, because at 5 they have the same y value. Notice that everywhere else the y's are different. Okay? So it says solve this system by using a table of values. Y is already alone, so I go to y equals and type it in, and then I'm going to go to table. Okay, so I hit second graph, and this is what I can see. And I have no idea what your calculator is set at. Mine is obviously set to start at negative 4.5, and it's counting by 0.5s. Okay, you can make your calculator start and count by whatever you want. Alright, so what you do is, to change it, is you go to second window, which is table set, and choose to start where you want and change the scale to what you want. So I started at, mine is at starting at negative 4.5 and counting by 0.5s. I'm going to change that, and I made it start at negative 10, and I told it to count by 1s. Okay, so you can change your table to do whatever you want. Alright, and then when I go to table now, okay, I'm scrolling and I'm trying to find like y values. And I don't see any, so I'm going to keep scrolling. And as I get up here to positive 5, oh, there was the system. Okay, so again, I found matching y values, which means my solution is 5, 4. To me, it's just, I mean, you can check the graph. I did the intersection and got the same thing. To me, instead of doing the table, this is faster to me. But on your tests and things like that, they're just going to give you, won't have the graph, you won't be able to get the graph. All you'll be able to see is the table of values. I don't even know if they'll give you the equations, but if you see a table of values and you're supposed to solve or figure out the solution, It's wherever the y values match. And then the answer is that x and that y. Okay? Alright, so on this one, it's not going to work until we get y alone. So if I take my first equation, 3x plus 2y equals negative 2, minus 3x minus 3x, 2y equals negative 3x minus 2, divide by 2, divide by 2, divide by 2, y equals negative 3 halves x minus 1. My second equation, negative 4x plus 5y equals negative 28, add 4x, 5y equals 4x minus 28, divide by 5, by 5, by 5, y equals 4/5 x minus 28/5. So if I go to my calculator and I type those in, and I go to table and I started at negative 2, and I found matching y coordinates right there. So my solution is going to be 2, negative 4. And I could check the graph, and sure enough, there she blows. Okay? Alright, so if we look at this one, again, to use the calculator, I'm going to have to get y alone. So if I take my first equation, negative 2x plus 5y equals 10, add 2x, I get 5y equals 2x plus 10, divide by 5, divide by 5, divide by 5, y equals 2/5 x plus 2. My second equation, 4x minus 10y equals negative 20, minus 4x minus 4x, I have negative 10y equals negative 4x minus 20. Divide by negative 10, by negative 10, by negative 10, I get y equals 4/10 x plus 2, which, if I simplified it, is going to be the exact same line. We already did this, actually. But, so what does that look like in a calculator? Again, you type them both twice, and when you go to table, obviously, you're typing the same line, so every y coordinate is the same, which stresses the fact that your solution is infinitely many solutions. They share all their points. Okay? What if you type this in and you scroll and you scroll and you scroll and you can't find equal y values? Well, it doesn't necessarily mean that there's no solution. Obviously, there's a solution because the slopes are different. If the slopes are different, I promise, your lines cross. All right? So if I'm not finding it, what can I do? Well, what you do is you start looking at the difference between these y values. And you see when they're starting to get closer and closer to each other. So, if I do 12 minus a negative 15, I get 27. 10 minus a negative 11, I get 21. 8 minus a negative 7, I get 15. 6 minus a minus 3, I get 9. 4 minus 1 is 3. 2 minus 5 is negative 3. 0 minus 9 is negative 9. Well, you see how, now it's going to start going backwards, but do you see how right here we have if I start looking at the difference in y values, I'm looking for values that are close together, or look for a sign change, and you see how I've got this sign change in y's? Anytime you get a sign change there, you know that there's a y-intercept somewhere in between there. So right here, there's a difference in those y's, okay, in those signs, so I know it's got to be close to there. So what that tells me to do is I'm going to reset my table to start at the first x value, which is this one. Okay, so I'm going to start at 1, and then I told it to count by 0.1s instead of by 1s, because obviously it's somewhere in between there. So then when I go back to table, and I look and I start scrolling, voila, there's equal y terms, but it was at a decimal. So my solution is going to be 2.5, comma 3. Okay? Again, that's why to me the table thing is kind of a pain in the butt. I just as soon type it in and calculate the intersection point. Alright, so solve this one using a graphing calculator. Hit pause, come back when you're ready. And hopefully you got 3, 5. And if I did that and I looked at the table, there's 3, y's match, so it's 3, 5. Alright, your homework is not on Math Excel tonight. Oh, so how can you find a solution to a linear system using a table of values? You look for matching y's. Alright, your homework isn't on Math Excel tonight. It is it's just a worksheet. It's kind of a fun one, hopefully. It says, solve each system of equations below by graphing. Cross out the box containing your answer. When you finish, print the letters from the remaining boxes and the spaces at the bottom of the page. So we'll worry about the puzzle in a second. The next couple slides, I broke it up for you, so you'd have room to work. Okay, so you're doing 1, 2, and 3 here, and I want the solution and the classification. Okay, so I'll do 1 with you so you can see how the puzzle works. But anyway, the first 3 you're going to do by graphing. The next 3 you're going to do, I want you to use a graphing calculator. And then the last 3, I want you to use a table of values. Okay, so you get a little bit of practice of those 3 techniques we learned. So let me show you how the puzzle works. If I do number 1, I would start at -1 and go up to over 3. And if I graph the second line, I'd start at 4 and go down 1, right 1. So it looks like my solution is at 3, 1, which means it's consistent and independent. Okay, so 3, 1 was my solution to number 1. So what you do is says cross out the box containing your answer. So the box that has 3, 1 I cross out. So you're crossing those out, and then whatever letters are left you print in these boxes, and it'll answer the question to the riddle. What were the headlines after a mad scientist trained 2 eggs to attack a candy store with sharp sticks? Wow. Anyway, that'll be fun. So, happy homeworking, and I will see you next time.